Let's attempt to find the slope of each graph at x equals 1/2. And as we are trying to do this, I'm going to introduce you to one of the most fundamental thing in calculus called derivatives. Let's look at the first one, y equals x. Well, it's a line. Y equals x is a line. And for the line, the stiffness of the line stays constant. It's always the same. And since the stiffness and slope are technically the same thing, we can think about the slope of a line as being the constant. It's always the same. And what's the slope of the line? Well, we define slope as the change in y over change in x. And in this case, change in y over change in x. Change in y is 1, and change in x is also 1. So we can think of slope as being 1. And since the slope stays constant, it's always tipped to the same degree. The slope at x equals 1 is going to be 1. The slope at x equals 2 is going to be 1. Slope at x equals 1000 is going to be 1. And slope at x equals 2, m, the slope at x equals 2 is also x equals 1/2 is also going to be 1. Was I saying 2? I meant 1/2. Now let's look at the second one. Now this one, it looks more complex. Now this one is a parabola, y equals x squared. How can we find the slope at 1/2? Well, the most fundamental thing you have to realize is for this, the slope or the stiffness is not constant. As you can see, the slope at this point is very low. It's actually 0 because you're not going up or down. The slope at this point is pretty high. You're going up pretty fast. Slope at this point is even higher because you're going up at a faster speed. How you can think about slope in this case, because it's not a line, is you can think about it as slope of the tangent line. Tangent line. And what tangent line is a line that's touching the graph at the point, but it only crosses the graph at one point. It might actually cross the graph at another point at sometime else. If the graph is going like this, the tangent line might cross it. But for the points close to the point of tangency, it's only going to cross at one. It's only going to intercept the line at one point. Now, what is the slope of this line? What's the slope of the tangent line? And this is where the concept of derivatives come in. How you can think about this? Let me redraw the graph of y equals x squared. This, when you plug in 1, you get 1. When you plug in 0.5, you get something like 0.25, and so on. Let's call this 0.25. It looks about 1/4. Now let's think about how we can find the slope of this line. This tangent line is the one that we're trying to find slope to. This is the tangent line. But since we don't know any other point on this line, if we know this point is on the line and we know this coordinate, we can use change in y over change in x to find the slope. But in this case, we cannot because we don't know the coordinate of any other point on this line except 1/2 0.25. So how you can approximate, since we cannot actually find it as for now, we can try to approximate the slope of the tangent line by using secant lines. And what secant lines are? Secant lines are the lines that intersect the graph at 2 points. And for example, this one is going to be a secant line, the one that's going like this. And you know this point is on the graph. Well, 1, 1 is also on the 1, 1 is on this line. 1/2 0.25 is on this line. So you can use these points to find the slope and approximate the slope of the tangent line. But you have to realize that's not going to be enough because this slope is obviously higher than the slope of the tangent line. So how can we make our approximation better? Well, we can plug this point maybe 3/4 of the way, and we can plot this point and we can maybe find the slope of this secant line. Let me be clear on this. We can find the slope of this secant line, this orange secant line that intersects the graph at 2 points. I'm sorry about my drawing, it's not the best. But even that's going to be a bit higher than the slope of the tangent line. So how you can actually get a better and better approximation is by moving this point closer and closer to our point. We cannot move it to our point, because if we move it to our point, the line is going to be tangent line, which we don't know how to find the slope to. And that's where the concept of derivatives comes from. Derivative is a way of finding slope of tangent line by moving this point ever closer and closer to the original point and evaluating the limit, the thing that the slope of secant lines are approaching as you're moving this point closer and closer. And we're going to look more into that in the next video.